Well, hello there, ladies and gentlemen. Hey, let's talk about graphing some trigonometric functions. Let's see what happens with these parameters a, b, and c. Okay, so what's going to end up happening is at this point you should already know how to graph y equals the sine of x, but what if it was y equals 2 times the sine of x? Could you handle that? Would you know what the 2 is going to do, like real quickly? What if it, instead of that, what if it was y equals the sine of 2x, or what if it was y equals the sine of x plus 45 degrees? So here's what I want to do in this video. I want to give you a quick overview of amplitude, period, and starting point, phase shift, because that's what A, B, and C address. So let's go ahead and explore this a little bit, and then we'll tie in how A, B, and C are related to these things so that you can quickly and easily sketch a graph of one of these functions. So like, for example, we know right off the bat, we should know that sine starts at 0, 0, and at 180 we have an x-intercept, and we also have an x-intercept at 360, 0, has a maximum at 90 degrees, has a minimum of -1 at 90 degrees, and the graph kind of looks like this. Do you see? So you should be able to sketch that pretty quickly. If that's not where you're at yet, you should just go back. I'll put a link in the description, and you can rehearse how to do this and learn how to do it, okay? Now, here's a couple things I got to get you to understand about this. Look at this right here. You see this right here? The distance from that middle point, from the x-axis to the highest point, is the same as the distance from that x-axis, that equilibrium line, to the lowest point. And that right there is called amplitude. So the amplitude for sine and cosine is 1. You see? Tangent doesn't have an amplitude because it just goes up and down forever in both directions. Do you see? But this has an amplitude of 1. So, do you see? There's a 1 times the sine. We don't even need to write that. Do you see? All right. Now, next thing we got to get you to understand is, you know how after 360 it repeats itself? So like starting here going this way is the same thing that happens at 360. Do you see? And it would continue a cycle, same thing. That one cycle from here to here is called a period. And for sine and cosine, the period is 360 degrees. This is the starting point. For sine is at 0, 0. The starting point for cosine is at 1, 0. Yeah? Okay, so now, let's see what happens when we do something like this, right? So let's go ahead and fill out this t-chart. So the sine of 0 is 0. The sine of 45 degrees is 707.707, same as square root of 2 over 2. And at 90, we're at 1. Do you see? So from 0 to 90, this is at 90 right here. From 0 to 90 starts at 0, goes to 707, and then to 1, right? Of course, it gets to all the places in between 1/2 and square root of 3 over 2 for 30 and 60 degrees respectively, right? But what about this now? What's this 2 doing to the sine? Well, the input is still x. The input hasn't changed. But now we're going to multiply that output, this thing right here, this output times 2. Well, 2 times 0, well, that's just still 0. So the sine of 2x is still going to start in the same exact spot. All right, now, the square root of 2 over 2 times 2 is the square root of 2. It's about 1.4. This times 2 is 1.4. Do you see? So let's go ahead and continue. If we multiply that times, we're going to get 1.4 approximately. And of course, 2 times 1 is 2. So the 2 times the sine of x, these would be our outputs. And so our graph, instead of going to 1, it now tops out at 2. And so the way that this graph will look is something like this. You see? It's going to have the same exact period. A doesn't change the period. It only changes the amplitude. It doesn't change the period. It doesn't change the starting point. We're still going to start here. We're going to end there. We're going to have the same x-intercept. The only difference is we're going to have a minimum and a maximum that are at whatever the value of a is. So here it's going to be at 2 and -2. So it's going to look a lot steeper. So it look like this. Do you see? So that's what a does. A increases the amplitude. So whatever A is, that's what your amplitude is going to be. So y equals sine of x, A is 1, amplitude is 1. Y equals 1/2 sine of x, well then the amplitude would be much smaller. It would be like this, do you see? That would be 1/2. Yeah. So A changes the amplitude. Okay, now, a little trickier to talk about what B does. What B does is it actually ends up changing the period. So here's the thing we're going to see. You're going to have your normal period divided by B will be the period of the new function. So like for sine and cosine, the period is usually 360, right? So you divide that by B, and that will be your new period for the new function. So if we're saying B is 2, well, 360 divided by 2 is 180. So what we should end up seeing is that we're going to have a graph, y equals sine of 2x, that instead of having a period take 360, it's going to take 180, so it's going to start here and end here. Oh man, we're going to have to draw a cleaner graph for that, but that's okay. We'll flip the page and just do that in a second, right? All right, so let's fill out our t-chart right here, right? So the sine of 0 is 0. We all know that. The sine of 90 is 1. The sine of 180 is 0, -1, and 0, right? So just to make sure, connecting the graph to the t-chart, sine of x, 0. At 90, it's at 1. That's the maximum. It goes back to an x-axis at an x-intercept at 180. And at 270, right, which is halfway between 180 and 360, have a minimum of -1, and then we're back to where we started, right? The cycle repeats. So let's see what happens with sine of 2x. Now, sine of 2x, so that means I have to double this input. So this would be the sine of 2 times 0. Well, that's still the sine of 0, so that's still 0, right? All right, now the sine of 2 times 90, well, that's 180, and that's 0. Oh, wow, that's weird. Oh, man. So we can continue with this. The sine of 180, well, that's going to be 360, which is 0. So here's what I want to do. Check this out. Well, let's go ahead and back up a little bit right here. Let's see, because we already saw that. So watch. Check this out. Let's put a couple other numbers in here. Let's put 30, 45, 60 in here, okay? So the sine of 30 is 1/2, right? So the sine of 2 times 30, well, that's the same as the sine of 60, which is the square root of 3 over 2, which is 0.866 approximately. Sine of 45 degrees is the square root of 2 over 2, which is the same as 0.707. But now, when we double it, like when we doubled A, when we used A, that doubled the output. What we're doing here is we're doubling the input. So this is going to be the sine of 90, which is going to be 0 again. So the sine of 2 times 45, same as sine of 90, right? And the sine of 60, well, that's going to be 2 times 60 is going to be the same as the sine of 120. And so that's going to be all the way up there at 0.866 also, 0.866. Do you see? So here's what we've got. Okay, so our regular graph, y equals the sine of x, looks something like this. Yeah, that's our regular graph, y equals the sine of x. This is going to be at 180 degrees. Well, when we do y equals the sine of 2x, what ends up happening is we go 0 to 30 to, so here's the deal. At 90, we're going to be back at 0 again. And at 45, we're going to have our maximum. At 135, we're going to have our minimum. So it's going to look like this. It's going to complete one cycle twice as quickly. So you could actually continue and do 2 cycles and they'd end at the same spot. Do you see? So B changes the period. Do you see? B changes the period. So it's 360 for sine and cosine. The new period is going to be 360 divided by whatever B is. So if you were going to do, say, y equals the cosine of 1/2 x, well, the period is going to be 360 divided by 1/2. You have to multiply by the reciprocal. That's going to be 720 degrees. You see? So, like cosine, for example, remember cosine starts here and ends here, and it has in the middle, right? So this is, say that's 360, this is 0, that's going to be 180, this is going to be 90, that's 270. At 180, we're going to have our minimum. So cosine looks kind of like this. Kind of ugly graph right there. But you get the idea, right? That's cosine, right, of x. Whereas if we did y equals the cosine of 1/2 of x, well, what's going to end up happening is instead of at 360, it's going to be all the way at 720. Do you see? So this is the halfway point, so we're going to have a minimum there. That's 1/4, this is 2/4. So that's going to be our x-intercepts are going to be here and here. It's going to end here, start there. So let's see if we can, let's see how ugly we can make this. Oh man, epic fail. Super ugly, but hand sketched graph, that's what they look like. So here's the idea. So far, here's what we got. A is amplitude, right? Super easy. Whatever number you see, that's the new amplitude. So if you had y equals 7 times the cosine of x, the amplitude's 7. So your maximum and your minimum is going to be 7. Works the same for cosine, right? B changes the period, right? So your period is going to be 360 divided by b. For sine or cosine, it doesn't matter. Same thing. Tangent too. Okay. So let's move on to the last part right here, shall we? Let's talk about what happens with, it could be sine or cosine, what happens with C, okay? Because that's where things get a little tricky. So C, what you're going to see, what you're going to find out is that a combination of C and B changes the starting point. So if SP is the starting point, it's called a phase shift. We take the whole graph and we move it left or right, okay? So let's use the case where B is 1 right now, and let's use the case where A is 1 right now. And let's say this is a 45 degrees, okay? So let's sketch a graph first, and then I'll show you. All right, so let's do sine. Sine's the easiest one for me. So up, not very accurate. It should go down as far as it goes up, right? But you got the idea. 360, 180, and 0. So if we had to graph y equals the sine of x, say plus 45 degrees, here's what's going to happen. Do you see this right here? There's going to be a phase shift, which means the whole thing's going to be moved, and it's going to be moved negative 45 degrees. So it goes opposite of C. So whatever C is, it goes the opposite direction. So instead of, if this is 90, that means that would be negative 90. 45, we're going to start about right there. And we'd end about right here. Do you see? So it would look like, let me give myself some targets. Let's see here. Instead of being there, it's going to be about right here. So it's going to look like this. Yeah, so this would be the sine of x plus 45. Moves it to the left by 45 degrees. Whereas if it was minus 45, well then instead of starting here, it would start there. Same thing works with cosine. Cosine starts here and ends there. The whole thing would get shifted. Do you see? Now, last thing about that phase shift. The phase shift, what you're going to do is you're going to take your original starting point, your x, right? So for sine or for cosine, we usually start on 0 for x, right? So what you're going to do is you're going to take that 0 and you're going to subtract C over B. That's going to be the starting point. That's going to be your starting point, and then your output, whatever that's going to be. So let's see what this means right here, okay? So let's do one more. Let's do one last example, and then we'll be done. So I know it's a lot of information, but that's okay. You guys can handle this. So let's do one all together. Let's do 3. Let's keep with sine, because sine's easier for me to graph. It's not more difficult to understand, just easier for me to graph. So let's do sine of, let's say, 2x, and let's do this time, let's do minus 60 degrees. Do you see? Sine of 60. So let's sketch it. Here's how I would prefer to do this. I like doing it this way. So I've got my function. I'm going to do a generic y equals the sine of x. Okay? So there's my generic y equals the sine of x. So that's right here. I don't know where to write it. Y equals sine of x. Okay, amplitude's 1, all that kind of stuff. So I'll make this 1, and then here's the deal. We have for y equals the sine of x, we have an amplitude of 1. We have a period of 360 degrees, and our starting point, our phase shift is 0, so our starting point is at 0, comma 0. Starting point's at 0, yeah, for x, right here. Okay, now, to figure this one out, here's what I know. I know that the amplitude, here, let's do it over here. So I know that the amplitude for our new one is going to be 3. So instead of having a maximum at 1 and a minimum at -1, we're going to have 3 and -3. Okay, now our period, here's our period. Our period is going to be 360 divided by b. The normal period for sine is 360, so I divide that by b, so it's going to be 180. So that means instead of going from here all the way over, it's going to stop right there. This is 180 degrees. You see? It's going to be that distance. Now, if I started here, I could just go, like if this number wasn't here, if that c wasn't there, then I could just say if this is, let's say this is 3 up here. So, let's see, that would be half. So our graph would kind of look like this. Let's say that's -3. So our graph would look kind of like this. This would be y equals 3 sine 2x. You see? But that 60 shifts it. So here's what we've got to do. Negative c over b plus 0. That's going to be our starting point. Starting point is going to be this for x. This is the x. So negative c over b, so that's negative 60 over, it's negative of negative 60 over 2. So that reduces to 30. Do you see? So instead of, so if this is 90, that would be 45. This would be 30. So instead of starting here, we're going to start there. Our period's going to go 180 degrees. So we're going to stop at 210. Do you see? We're going to stop right here at 210. And so we're going to go all the way up to 3. And we're going to end here. So halfway, that looks like halfway. We're going to have an x-intercept there. A quarter way, we're going to have a maximum. 3/4 way, we're going to have a minimum. So it's going to look something like, this is really horrible. It's going to look something like that. This one right here. So let's see if I got a, I have a highlighter right here. So this last one we did, I know it's kind of tricky. You're going to have to practice this. I'll leave a link in the description so you can get some notes and some practice problems. This one right here, that is 3 times the sine of 2x minus 60. Now, if you weren't sure, if you're learning this and it's all kind of confusing and new, here's what I would do. I would try it on paper on my own, just following this, right? So your first thing you're going to do is you're going to figure out the amplitude, you're going to figure out the period, you're going to figure out the starting point. And once you figure out the starting point, then you can figure out where it ends. You can figure out where the x-intercept is, where the maximums and minimums are. Same thing would work with cosine. Boom, you're done. So I would do it on my own like this, and then I would plug it into graphing software or Desmos and see how you did. So I know this is a complicated thing. We covered a ton of information. And it might be a little overwhelming. So check that link in the description so you can kind of learn a little more. You can go a little slower. You can see some examples. You can have some practice problems and all that. Hope it's been helpful. You guys have a great day.